Comparing two means, our tutorial. In the lecture today, Jeff extended our discussion on two-sample inference by introducing the confidence intervals and hypothesis tests used to compare two means from two independent samples. The example we will focus on will be for the skeletal remains dataset. Let's read it in and attach the variable names, and with the head command we will view the first few observations. We wish to compare the age difference between males and females, so we will have to split up the dataset. Recall that the variable sex has been coded such that 1 indicates a male and 2 indicates a female. So we will define a new variable male diff, and we will set it equal to a subset of skeletons, our dataset. To index into the dataset, we will use square brackets, the first entry being the rows, where sex equals to 1 for males, and the second entry being the sixth column, which contains the DG difference variable we are interested in. And similarly, we will do this for the female differences. If we want to calculate anything by hand, it would be useful to obtain the sample size with the length command, the sample mean and the sample variance for both groups. And we can even find the critical value from the t-distribution with the qt command. But we can also let R do all of the work. For a two-sample t-test, we can use the command t.test, specifying the two independent samples, male diff and female diff. Notice that there are no additional arguments given. The default arguments are just what we need. The alternative hypothesis is two-sided, the null hypothesized mean difference is 0, and the confidence level is 0.95. Our conclusion from the confidence interval is that the mean age difference is higher for males by about 1.03 to 7.37 years. This conclusion is supported, of course, by the small p-value, from which we can reject HO and conclude that the true mean age difference for the male skeletons is different than for the female skeletons. You can also specify an extra assumption for this hypothesis test, that the two population variances are equal, with the var.equal is equal to true argument. This changes the test statistic in degrees of freedom, and therefore the p-value as well, but our conclusion remains the same. There is a significant difference between the mean age difference for the male and female skeletons.